Hello fellow learners, welcome to Maths Bridge. We train, you can learn. Thanks for joining with us in building a technical competent community. We shall continue our C programming learning journey. Let's get started at today's topic. Folks, please do visit us at our YouTube channel Maths Bridge. I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. Storage classes. A storage class defines the scope, means a visibility of a variable or lifetime of a variable in the execution of a program. So it's very essential for us to understand how this scope within a C programming for various variables that we do declare and use for managing the program, right? So there are the four storage classes which we are going to look at in detail, but they are auto, is also known as a local, register, static, and extern. These are the four storage classes which we use in our C programming practices. Memory organization which we use in C programming. Let me recall you what we discussed in very first session of a C programming. Go back and look at if you would like to look at the details. But here the context, the reason for showing here is we have a different memory segments. Each segment we use for the different purpose. So based out of the scope and visibility, we are going to use them. Like we use stack variables, we use static variables, we also use uninitialized variable, constant variables, also known as a read-only variable. This is one thing that we are going to talk about. Our storage classes, one way or other, referring these sections. Here is the typical architecture of 8085 microprocessor. Microprocessor is a central processing unit of your computer. So when CPU is actually accessing the memory, it will access external memory or internal memory. Internal memories are much faster than external memory is what we see in terms of accessing. Accessing could be like for the read operations, for the write operations too. Read cycle and write cycle are different from memory to memory. If you look at like a internal memory is much faster than the external memory. So based out of the context, if you look at functionality point of view, you might not really see the difference, but performance perspective, like there is a need of choosing like what sort of variable that you are going to declare, but that also tells you like speed and performance. So the reason I'm showing here is that one of the storage class called a register, there are instances where you can declare a variable as a register. That's the reason I just brought it up onto this context, so that we could correlate when we are actually talking about a specific storage class. Okay, let's have a quick test. Look at this sample program which I displayed. Do you think it is going to compile without having any error and warning? It is a straight simple, right? We have a main function, we have a sub function called my function. We are calling my function from main function. This is like a very simple function how we are using in programs. We know that, right? Why we require a function. Function is like a subroutine for repeated tasks. We are segregating the piece of code into a function. We can keep calling as and when there is a need, right? Otherwise you end up actually writing a duplicated code, which is not a good practice while writing your programs. That's why you wisely think how to create a functions and then based out of the need purpose. Anyway, currently if I could compile this code, I would expect a printf message being called by the main, and then you could see the console like I am learning C storage classes. But is it really compile? Well, let me see, if I can compile this piece of code. What happens is like it throws an error stating that there is a conflicting type of my function. It is just warning, but however it produced an output. You could see output, obviously. So, but the reason is like a good practice is always try not to leave the, the warning messages. Okay, then how to fix this problem? Here is the solution. So when you are using like a functions, you declare a function prototype before the main. This is one way to fix the warning message. If you do so, then it is going to, compile with clean, and then you will see the output as is. The reason I'm, bringing this, topic on this context, because most of the times when I use functions, I use a forward declaration, and hence to avoid that confusion, I'm just giving this thought process. Let's look at this, the program to understand the how local storage class works. So I extended the previous example, like I have a function subroutine called my function one, where I declared a variable as an int, initialized to 0 and incremented and print the value in it. Okay, so now I'm calling this function twice from main program. That is how it works, right? What I will do, like I will compile and then see output. From there I can understand like how this function works. Do you see now I have a three statements, printf statements, right? Main. So I have a printf statement in line number 9 at main, within the main, right? So that's good. So basically this macro brings the the printf statement wherever executes. Basically this picks the current function name and then prints on the console. That's an idea. Here is like we are in main, so we got a C, main is a string. That's good. Now I call like a my function one. When I call this function, what I should display, my line at 19, line number 19. This is what I'm seeing, like the variable value is what I'm displaying. Can you see now? Okay, I am in function my function one, and the value of number is like 1. Since I called twice, I see the messages twice. That's good. But what is interesting topic here is every time you call function, this variable getting initialized to 0 and incremented by 1 and then displaying. Got it? So if you understand little more topic of this one, this is called a local variable. The local variables means like the scope, the visibility is only limited to this function or this block. That's what I'm saying. So these variables where it will be allocated in the memory, it basically occupies a stack. Stack memory is what the C compiler uses to allocate the memory for these variables. That's an idea. If you don't initialize the value, by default it gives like a garbage value. So you have to make sure you have to initialize the variables properly. A good practice always initializing the variables when you declared. But today if you see like there is a warning message always throw saying that you have a uninitialized variables. Okay, the scope is limited to the block that we discussed. Within the block you can see the scope. Outside of the block you can't access this variable. If you try access this variable from the main, you are not, because the scope, the visibility has a concern. So life is only end of the block. The minute you come out of this the end of the block, then you're done. Got it? This is how a local storage class works. Let's look at now the concept of auto storage class. I have the same example, but what I did is now I declared integer number as an auto. By default, it is an auto even if you don't define it. But so that way I could see like auto and local both are same. If I can compile this code, you know what I get is same output which I have seen in previously. The scope is also same concept. Then access specifier auto and local both are same. Whenever I say like local variables uses a stack, okay, as a storage area. Default initialize it to 0. Default it is gonna be garbage, so you make sure you initialize properly. Okay, the scope is limited to the block. Within the block only you can see the visibility. The life, it is going to be die after you exit from this end of the block. That's an idea. The life is also limited to the block. So what I'm trying to tell you, like auto and local both are same. The keyword auto, if you don't see it in your definition, then it means like by default it is treated as a auto variables. Register storage class. Let's look at this. I have the same the problem statement, I mean the program. What I did is like instead of auto, now I made it like register. If you can compile this code and then see the output, really I don't see any difference, right? So autos are same, got it. But what is actually more advantage that we are going to get by defining data type the variable as a register? Here is the context. So storage specifier is known as a register. When I say that, the CPU registers is what allocated for that this variable, and then default the value of register type variable hold with like in a garbage. So you must have to initialize it. The scope is again, this is treated as like a local variable in this context, and hence the scope is the visibility is only within this block, and the life of the variables also ends at the end of the block. Let's look at the concept of how static storage classes works. I have a same example problem, but only thing now instead of like auto, now I'm auto register, now I'm defining as a static int variable initialized to 0. That's what I did this now. So if you can compile this code, what happens is like, do you see there is a difference in it? What the difference? The first time when you called, and then this variable get initialized to 0, and then now you incremented, and hence whatever the value number 4 variable number 4 is holding is what you get it, that is like 1. That is fine. Second time when I called, then what would happen now? I should expect a 1, right? But I got a 2. The reason behind is like the second time when we called, whenever you see the static you know um, variable, that variable is never going to be initialized again to the 0. Instead it holds the previous value. The previous value means like the first print of what you can see 1. Because it says 1, it is now incremented by 1 more. So 1 plus 1 is 2. That's what I'm seeing. So what this means, like it gives you two important points. First thing, the storage specifier is called as a static, and then where it occupies. So these type of variables will be allocated in data segment. You see there is a stack, data segment and all, right? So this is in the data segment area, not in the stack. Next one, even if you don't initialize this to 0, by default it takes 0 value. That's the advantage of static. But is it like every time that you are going to use like a static? No. There is a real reason for actually using static, but otherwise you end up actually run out of the memories. Okay, that's a thing. So next one, the scope is limited to only within the block. The scope is limited to the block, but life, if you look at, even after you came out of this function, but still this variable exists. That's important. That's the reason second time when you re-enter this function, it looks the context of the previous one. And then what I would say, the life of this variable is entire program. It ends when you end the program. Till then, this variable is active, but only thing is like you will not be able to access it elsewhere except, the scope is limited to within this function. Are you clear? So static storage classes are important concepts in C programming. For instance, any other programming language. Now let's try understand the concept of external storage class. See, typically you think a simple example. When we are developing a project, the project is nothing but like a bunch of files, right? There is a many source files. Not that like always you go with like a one single source file, correct? So you have the multiple files. Let me tell you the use case that you are in one file, but you are trying to access the variable from other file. How you are going to do that? Because you need to understand the lifetime of that variable, scope of the variable, means visibility of the variable, how you are trying to access that variable, correct? So basically what I'm trying to tell you is like we are bringing the concept called a global context for all the files, not just only the one file, right? That is where I think I'm using the keyword called extern. So external storage classes. Let me take a look at this in a simple example. I have a main function where I am trying to access a variable which was not declared within this main. But in order to avoid the compiler confusion, what I did that in line number 7, I made it like a extern int var. What this means is the variable was declared elsewhere, but I am trying to access from this file. That's what mean by it, isn't it? So where it would be then? So I have one more file, for instance, called extern function, where I declared variable and then initialize the variable here. So to get the visibility of this variable, I'm using extern int var, and hence my main understood now that this variable which I am accessing is defined elsewhere, but I have a control now. Got this? So this is what called as a external storage class concept. Okay, if I can compile this code, what happens is that I got these messages. You see, twice I called a my function which I defined in different file, but that is simply like printing a simple message. That's good. But you also look at like a variable got initialized to 10 in external func dot c. So since I'm having a visibility by external keyword, so I could see print out as a 10. Got it? So this is what it is. So now look at like in a summary. Storage specifier extern means all the external variables are using data segment. By default, if you don't initialize, default value would be 0. Okay, the scope, the visibility is like global files. All the files in the project probably will have visible get a visibility of this one. And then life, it exists in complete life cycle of the program. Okay, it ends, the life of the variable, external variable ends at end of the program. Got it? So that's why like these are the takeaways for this external storage classes. Here is the summary. Auto storage is like a stack. Garbage value if you don't initialize properly. Scope is like within the block. End of the block. Life. If you see the register, it is a faster access. Otherwise, property wise, default value is garbage. The scope is like within the block where you declared register variable. End of the block is what your life. But it occupies a CPU register set instead of like a stack at the data segment. Look at now a static and extern. Both actually occupies the data segments. Default value for the static variable and extern is becomes like a 0. Right? If you don't initialize also, it takes as 0. And scope is a little variant here. The scope of the static variable is like within the block, but extern is like a global for all the files within the project. these two, having like a complete programming life cycle. So end of the program only these will die. Until then, it will exist. You got this? So all these storage specifiers have their own context of properties. You just understand the concept and then try use them in your program. So storage classes are very, very important. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.